Hi everyone, and welcome back to another ET Talk. I'm Cole Camplese, Vice President for Technology and Chief Information Officer at the University of Texas at Austin. And today we're going to do something a little different. We've been talking about so many of the things that people see on campus. One of the more interesting things that we do, and I think one of the more surprising things that we do, is not only do we manage this network for this massive R1 institution, but we also have a team that thinks about the wide area network that connects the schools around the system and around the state of Texas. So I thought I'd bring two of my colleagues here today. One, John, who's the AVP of infrastructure for the organization, and JJ, who focuses mostly on that wide area network piece. But I just am so thrilled to have you guys here. Welcome to the podcast, guys.
Yeah, thanks for having us.
JJ, why don't you tell us a little bit about yourself?
Sure. I'm JJ Stonebraker. I am the director of the Office of Telecommunication Services, which is a really interesting business inside of UT.
Yeah.
We do work for UT System, but we are badged employees within UT Austin. OTS has actually been around since 1984.
Has it really?
Yeah. The guy that actually invented it and created it, he's still actually on payroll. We actually keep him. He comes to Monday meetings, and we'll let him tell us stories about where this thing began.
Where it really started.
We have diagrams of it. It was when the very first supercomputers, the VAXs back then, were put together, and they needed to do what are called X25 connections. It was 25 kilobit connections that they did, and we have pictures of this original version of it. But that network has just grown.
Yeah.
And now it's this 400 gig network that we run today. So yeah, Wayne's still around. Shout out to Wayne Wiedemann.
Well, that's great, Wayne. Thank you for that and getting us off the ground there. And John, how about you?
So I'm John Lovelace. I'm the AVP of infrastructure, as you mentioned. I've got the wide area network team that JJ runs that falls in my portfolio, as well as the on-campus network, the voice services group, the data center, building security, and a handful of other teams.
Yeah, and I think we're going to get together with Mike Martell from the data center, leading the data center team next week. And there's a rumor that we might hit the lanes because Mike's an incredible bowler from what he brags about.
Looking forward.
Yeah, it's going to be fun. Nothing like getting embarrassed live on your own podcast. But so, guys, I don't think people really get now those of us that work in technology understand the critical nature of the network. But talk to me a little bit about what it looks like as an R1, the number of clients that connect, because we have faculty that don't want to move megabytes, they're moving terabytes of data. We have HPC that requires as much bandwidth as we can give it. What does it look like on any given day running this thing for the University of Texas and then for the state? What all's happening behind the scenes there?
Yeah, I mean, so our group actually looks like an internet service provider, and we operate like an internet service provider because at the end of the day, be it for collegiate reasons, we are an ISP. So all the research, all the infra, all the data, all the students are tied into this network and basically sharing it. And it's not just us either, because we co-run what we call the TXBB, it's the Texas Backbone, with TAMU. So that's two systems.
For those of the folks outside of Texas, TAMU is
Texas A&M University.
Our friends out there in College Station.
Our friends at College Station. Yeah. We go through and we have those packets actually intermingle.
Yeah.
And we share it. They actually take care of the east side and their capital partners as well as operating partners. And then we take the west side and glue it all together to make this triangle, this 400 gig triangle in Texas. But I mean, John can speak actually on the edges for campus. I do what John will describe for 13 campuses. Some of them are healthcare, so you have all the HIPAA and FERPA data.
Yep.
But we're basically like the super highway to make sure that we don't really look inside the packets. We just get the packets where they need to go quickly.
Yep.
And then once it kind of off-ramps into a campus or an HPC cluster or out to the internet, it's then processed.
So then when it would land on a campus like UT Austin, John and the other half of the team take that and they do the management of the LAN or the internal network.
Yeah, exactly. So basically the edges of these campuses, they're like, when it leaves this 100 gig port, I'm basically out on the superhighway. I'm headed to the internet, or I'm headed to Internet 2, or I'm headed to another school, and OTS is going to get me there the fastest way possible. And so it's just a different lens that we have to look at the infrastructure. John and I were talking about wireless access points. That's not in my world. That's the two words here. LAN is for local area and wide area is what we do. So don't think about wireless access points. I'm just trying to get petabytes of data. As
Availability.
Fast as possible. Yeah,
Yep.
availability. And running, 4 nines of uptime, we treat it like an ISP would.
Yeah.
There's 911 and emergency services.
Everything runs on that.
Yeah.
And, we were on the senior leadership committee, or I don't even know, council. It's the system-wide
Yeah.
CIOs and health CIOs. And you guys, what's interesting is I get to sit and bask in the glow of your updates every quarter, because it feels like the work that we're providing for these other campuses, I mean, it really is a lifeblood.
Yes.
And we do it at a cost that is actually fits within the boundaries of higher education. The system helps support our work. It's really quite an amazing view of shared services, if you think about it, and
Yeah.
inter-campus cooperation.
I mean, the economy of service, having all of those institutions be able to leverage shared resources, and still we manage the capacity so nobody is running up against any sort of limits. Half the job is basically forecasting what they haven't told us is coming down the pipe yet and making sure that we're overbuilt for when it shows up. That's all it
Interesting.
is knowing that when you say, hey, we're going to break ground in 2030 on this hospital, figuring out about how much bandwidth we think is really going to show up on the
Yeah.
network and making sure that we have the headroom. Because I'm basically doing the plumbing, that's what we're doing.
Yeah.
I'm doing the plumbing further up to make sure when they come online, the spread of traffic is going to look like this. It's going to go to these places. Do we have that capacity?
And what's fascinating, we'll get to the hospital in a little bit, but it's so interesting because we're building this 400 to 600 bed hospital 15 miles north of campus at the old J.J. Pickle site, which is going to require all sorts of new infrastructure. And I'm sure we'll talk to Mike about, is there a data center? What about power? What does it look like to light that campus up? It's quite the program.
Yeah.
It's going to be a hell of a 4-year ride, I think, for all of us.
Certainly.
So John, like when you hear all of that and you know all of that's going on, the other half of your team is using all of that infrastructure that gets dropped off to campus. Talk a little bit about what the team does then once that hits campus.
So it was interesting you said, what does a typical day look like?
Yeah.
One of the things that I love about this job is there's no typical day. So there is, on any given day we're supporting massive amounts of users. So on a semester, we typically have about 550,000 unique wireless devices connect to our network, another 150,000 wired devices, everything from a laptop up through research instrumentation,
My car.
healthcare equipment.
My
to
car
your
is connected out in the parking lot.
Yes, yeah. So we do have to support all that work and over the course of semesters push petabytes of data. But then, depending on where we are in the year, this time of year, for example, with a little bit lighter load from a teaching perspective, we're doing a lot of life cycle upgrades. So we've got teams across campus working with folks in various buildings to upgrade their equipment. We've spent a lot of time and effort, and thank you for all your help. Establishing some new models around that. But we've done a lot of work modernizing the network over the course of the last few years. But at various times of the year, we're supporting events, football games. We've got construction activities constantly going on around campus that we're weighing in and playing our part in building the new campus.
And it's fascinating. I had Brent Stringfellow on the podcast, and we talked about actually the similarities in our teams, especially in the construction and planning space.
Yes.
And, before I was in the CIO chair, it's been years now, but it didn't occur to me how engaged the CIO's office was in all of the campus construction. I know that sounds funny, but I came from a teaching and learning with technology background, and I just sort of thought, well, hell, those wires must just grow out of the walls or something like that. But the collaboration that I've watched, especially between your teams and the facilities group, has been really impressive.
More and more these days, when a building gets commissioned before the first user moved into it, there's hundreds, if not thousands, of devices connected within that building.
Because you mentioned it, everything from a laptop to TVs to sensors, air quality, HVAC, life safety, vending machines. I don't think people quite understand that on a connected campus that almost every device is an endpoint.
It is.
It's pretty fascinating when you step back.
We got IPs on light bulbs.
Yeah.
Which is wild, but it's the Internet of Things.
Well, and I mean, like even my house, I have something like 86 devices connected to my network because my light bulbs, my switches, the computers, the phones, everything is connected that way. How do you guys, so JJ, you mentioned a little bit about having to have a little bit of a crystal ball and projecting what campuses are doing. Part of that's easy because we have a natural flow, right? Students come back, it's the holidays. What are the other kinds of events that happen throughout the year that makes you go, oh my God, we have to prepare for something big that's going to come?
You know, there's interesting ones that happen because there's so many students here. You go through and have something that I'm thinking of the big ones that we actually had to encounter. The solar eclipse. Everybody
That's
gets
right.
on the stream,
Yeah.
and then all of a sudden we basically see it looks like a DOS attack because we go, where's the CDN, which is the content delivery provider of this, wherever people are watching the
Right.
content, and we basically just see a ton of traffic rip through Dallas, start coming down the core, and try to hit all the campuses. But it's concentrated because that eclipse is 8 minutes
Yeah.
or 11 minutes long. So huge amounts of data that actually, but we know when the eclipse is going to happen.
So you guys actually sat back and said, this is going to be an issue.
Yeah, we're pretty good at actually knowing major events that are probably going to be watched or televised and engaged with. And the hard part is there's not really mitigation that can be done. We can get creative by where we route the traffic. We go on a given day. You know, if you think about the plumbing of Texas, everything comes through Dallas. There's a building called Equinix or a building called Infomart, but it's like the artery of
Yep.
Texas. So we know that's where the traffic is going to come in.
It's like New York City for the...
Yeah. There's two major entry points. Dallas has Equinix, and then we touch Equinix where AWS East is in Ashburn, Virginia.
Okay.
We can be creative in going on a given day. We want to take everything through Dallas. That's going to be the best latency. But we know this big thing is actually coming up. We're going to split the traffic between two of these in preparation so we don't fill up one side. We're going to use the whole network rather than the network being designed kind of in a triangle or circle where this is active, we fail over, this is passive. We're going to make it active for this. So it's that sort of thing to be able to look at it and go, okay, when would we need to do this? Can we plan for it?
So it's not a set it and forget it kind of an environment.
No,
Like
no.
every day is truly a unique set of opportunities and challenges.
Yeah. We try not to touch it too much because as important as that triangle is, it's commodity and we want it to be like the power.
Right.
People just assume it's there and it's working. So we have to be very thoughtful and cautious about when we adjust things. But that's part of just the running of it. You can evaluate and make some decisions, and we talk about it in our Monday meeting, and then we'll go through and say we're going to change this around. Yeah, that's really the pieces. The other ones are unplanned outages, but we design it to be fault tolerant. It's self-healing. It cuts. Traffic leaves here, goes to this other place, and then there's basically just an economy of failure we would actually have.
Yeah.
But it's basically we keep an SLA and we got to keep business continuity.
Well, and it's interesting. I mentioned those SLC meetings, and what I find interesting about you too, like John, you arrived in this place from places like GE. You came in with an MBA, right? JJ, you're really a self-taught, hands-on engineer who started in EE. Couldn't find the pathway into networking and sort of built your own career. John, you have to bring a significant MBA mindset to your work, and I think that's another thing that folks don't see. The network is really one of the most expensive and most prized assets of any office of the CIO, right? Like, I firmly believe, and I've said this to you before, when the network goes down, we cease being an R1, right?
Yeah,
because
that's right.
I challenge you guys to think of anything that our researchers do without the network in any meaningful way. How do you bring that that business mindset to what really looks like very technical architecture and engineering work? And just talk a little bit about the importance of knowing your business. Because to me, the most impressive thing that when I got here and I recognized about you was that you truly run your entire operation like a business.
Yeah.
Your forecasts are very accurate. Your budgets always reconcile.
Yeah.
Talk about bringing that kind of discipline to an IT organization.
Yeah, no, I think in all the ways you describe, it is a business, right? It's not necessarily a profit-motivated enterprise, but it is a business, right? We have an objective that we set out to maintain. We have stakeholders performing very important functions. and we look to do that in a, while balancing investment and, operational resiliency.
Yeah.
And so we spend a lot of time looking, one of the big mantras that we've had over the past few years is moving from a more reactive to a more proactive mindset. So we've spent a lot of time on tackling technical debt and upgrading the network. A few years ago, it was not uncommon for very old equipment to fail with some, regularity
Yeah.
at inopportune times. And when a piece of equipment fails and takes out several classrooms, during a typical workday, that's problematic. And
Absolutely.
so we've spent a lot of our effort on trying to get ahead of failures, making sure that we've got equipment that's managed to a reasonable life cycle, investing in our monitoring tools to catch issues before they become apparent
Yeah.
to end users. The AI tool capabilities of the future are super exciting in that capacity because we see a lot of opportunity. When we have a failure in a particular area, we can do a root cause analysis and go figure out what happened. But what we're trying to get to is to determine what is going to cause that to happen before it fails, so we can get out ahead of that user impact. It helps us from an operational perspective, and it certainly helps from the end user's perspective to not have that failure occur.
Yeah, and so talk to me a little bit about what you inherited here from the perspective. You mentioned life cycle. I've heard your stories because I've only been here a couple of years. I'd love to take credit for all the great work you guys have done, but I mean, you all built the plan and you've been executing on it, and you did it at a time when there weren't really dollars being made available to support IT in the same way. But you told me some stat that a decent percentage of our networking switching gear was old enough to drink.
We did have switches as old as 22 years old, so they were old enough to drink. A statistic I'll share: we had a little over 1,000 switches when we started working on this that couldn't be security patched, and that was really the red line for us.
Right.
That the historical model for funding and evaluation, through no fault of the folks, working to manage it, but we needed to rethink things and come at it from a different perspective. And so we set out first with the most vulnerable of the equipment, tackled that in the first year, and then have worked with you and university leadership to establish a more sustainable model going forward to make sure that equipment stays up to date from a security perspective and from an operational resiliency perspective.
Yeah, because both of you know a network is not something you rip and replace. Right? It's a living organism in many ways that you heal, repair, invest in over time, and retire elements. And when you're making judgment calls on whether I buy a switch or invest in a new researcher, as the colleges were doing for so many years under the old model, if I'm a dean, I'm choosing researcher every single time until that thing breaks. But again, one of the other things we've done is we've sort of shifted that model as well, haven't we? Where we think more about, we've even treated it a lot like you did, JJ, where we dropped connectivity off at a building. The team there took it over. How has that dynamic changed now that you see that we're doing more inside people's buildings in addition to their own networking teams?
So we've always had a balance of ownership in terms of be it funding or operating, but I think what we've tried to do is partner with our campus stakeholders in a vision that we've called our next generation network, and elements of that involve life cycle sustainment and whatnot, but we're starting to kind of move up the stack and look in other areas around creating true network security profiles where we can isolate the appropriate equipment and onboard folks in the network in the appropriate safe, secure environments. We're looking at Wi-Fi optimization across campus. So
well, you have a number of infrastructure projects: the Wi-Fi optimization, next-gen network, the mobile credentials even land, interestingly enough, for a lot of people in the network space in a lot of ways.
They do in a lot of ways. Yeah. And so it's really an opportunity to homogenize the experience for folks across campus. To ensure a resilient operation for our students, faculty, and staff, regardless of function and regardless of where they are across the university.
Yeah, and it's interesting. I had never really thought of that. You said that it's part of their experience, that in many ways, again, the network is sort of the foundation for much of the experience here. Like, you can't register for a class without
Yeah.
a smooth experience on the network, tied to identity, et cetera. So, JJ, I'm curious, like, you're dealing with all these other campuses, and I know nothing ever goes wrong, right? There's never a catastrophe or anything, but
It's generous.
let's pretend that there was a catastrophe.
Sure.
How do you and your team triage that at distance and think about that? Because you may be trying to get to a circuit that's several hundred miles away that's causing a problem. How do you think about that from Austin, connecting all of this? So when it hits the fan, what does it look like with the team?
Yeah, so I think the dividends are paid in the design. So you have to design knowing that we take fiber cuts all the time.
Yeah.
And that's just part of.
I mean, here on campus and everywhere.
Yeah, everywhere.
Yeah.
I mean, the construction, TxDOT relocates. TxDOT said there's a new freeway coming here, so I need you to move a bunch of fiber, and okay, so we have to do that. So you design the network. There's like a philosophy. It's N+1 redundancy. I can take one failure. We've paid for having that failure. N+2, we start to get really statistically insignificant.
Mm-hmm.
But also, if you want that, you can add a few more zeros to the budget of trying to do that. But what does it actually buy you?
Right.
If at the end of the day is that experience impacted? Is research happening? So we get away with basically our SLA. The team has designed the infrastructure that we're not afraid of cuts. They just happen. And then we go into running our plan to go execute. I mean, what's probably not known, we have one man. Texas covered by one
What?
man. Yeah, just one man. We're gonna have two.
We got to
probably a
shout that
truck.
one. We got to shout that one man out.
So Bobby Wawak.
Oh, really? I
yeah,
didn't know that.
Bobby Wawak has been around. He's probably been here for 35 years, something like that. He's one of the old, and that guy is on the road and will go out, and we have team in other cities now. As the network has grown, but he'll go out there with equipment. That was where we started. Now that this infrastructure has grown and we've matured, we run depots. So I basically have equipment that's up in the Dallas area that can be acquired. I have an engineer that's actually in like North Waco, and he can actually cover Dallas. We have our partners at TAMU that can help cover Houston.
Mm-hmm.
But as far as our fleet, it's that van and running around to go grab stuff, including remote sites when it's something like the McDonald Observatory.
Yeah, because we had just an issue out there recently.
Yeah, so it's a coordination effort. It's understanding. I tell the team, I'm only going to hold you accountable for these SLAs, and we clock outage minutes when basically we've created impact,
Mm-hmm.
not when we're just actually N+1 cut.
Okay.
So that's not counting that we're down, because nobody knows that we're down. We're down in the way that we designed for. If we're really down, it's because we got cut and somebody is impacted. But the network, we run this technology called MPLS. It's like a self-healing fabric. So you can cut it in one place, and what is a circle becomes a line, and the line is good enough.
Wow.
And then when we actually go through and fix the problem, the circle reforms. But it does that for all of the infrastructure underneath it. The way that I know it works well is if, Jason tells me we didn't drop any packets. I was like, we were down for 6 hours.
Wow.
But you didn't know it.
Yeah.
Then job well done.
So when it does go down,
Mm-hmm.
and I assume it's different people, but who do you hear from first? Like, who are the people that you hear if there's an outage? And I know you said you're at 4.9, so it's tough to find it, but
These days, which is amazing because I love it, it's the agents. The
agents.
Yeah, the agents know first because they're watching. What it used to be, depending on time of day that it actually goes down, since the network never sleeps, and off hours, the operators over at UDCC, they have a view into our network and they see our NMS. So when they actually see that, they have a run
so you
book.
see it, you usually get the notification from within
Yeah,
before a customer.
Yeah. Well, ideally, the perfect world is I never want to learn about an outage from a customer.
Right.
That's the wrong way that I'm getting informed. I should have enough telemetry to know, and then the customer information is just getting added to a ticket that I already had open. Perfect world is customers learning from me that I'm impacted.
Right.
even if it's not materially impacting them, but like the network has gone from that circle to a line. I'm just letting you know we're in line state right now, and we're working on it. You're not seeing anything, and I'll let you know when we're back up. Agents have allowed us to start to get to that level of inference and speed. So they're the ones that know first, and they're wired into our Slack, which is wired into my phone.
So I want to poke at that a little bit, because I know you and your team have been very early adopters of using AI for these kinds of purposes. What are some of the things that you're really proud of that you've been able to do in these really, because we are still in really early days here?
Yeah, no, it's very early. God, there's so much. I'm proud of the team because our team AI works well because it is a mixture of human creativity, code,
Mm-hmm.
and then this part we were missing, which is agentic inference. We've commoditized intelligence,
Right,
so you can now apply intelligence for the cost of a token
right,
to something you care about. And everybody has something they care about. From a business perspective, I care about the state of the network. So I can have this team take these agents, and we can figure out how do we take these agents and chain them together to perform a function. The difference between talking to an agent and it being able to tell you how to do something on the network is 0 to 1 when an agent can just do something on the network.
right,
It doesn't have to explain to you, because I'm trying to get cognitive
right.
load back.
Yep.
I need you to do it, but I need you to do it safely and by a set of rule books. So, Angelica Delgado on our team has been just like rocking and rolling, and we've been building a bunch of these agentic, frameworks, and we're wiring them into like the tools that we use for communication every day. So really neat stuff, like when we do planned maintenance outages, the agents actually snapshot the network before and after. And so my team is going and working off a mop or a method of procedure. They actually execute on that. Maybe something goes wild halfway through the mop. They have to back out or change or pivot, and they're up till 6 a.m.
Yeah.
So Pete's like super tired, but I need to know what Pete changed so that morning crew comes in and we're aware. Sometimes that's hard. Sometimes it's forgotten. Sometimes just the information is after working is not great.
Yeah.
Now the agent snapshot before and after, read everything, see where we were on the actual mop, saw where he actually turned off, and said this is where we actually ended up. And so I have the agents give like a brief at 8 a.m., 12 a.m., and 4:30. They sign off at 4:30, and they're like, "We'll see y'all." Like they talk like if you ever talk to an LLM, I mean,
No, I get it. And I think that what I'm really excited about over the next couple of months is folks like you and your team sharing that insight across enterprise technology.
That's one of my goals. Is the valuable thing I think I have been able to produce is figuring out a way to wire these things together so that no matter how you want to apply it,
Right,
here's a method.
right,
Here's a method that allows this fabric of these agents done this way. It doesn't matter what you put into the A, what's going to come out on the Z side will probably be valuable. It's not perfect, but we have this method, and then we can share that. I think that's agentic orchestration, is people learning, and oddly, to be good at that, 30 years of networking experience helps.
I think that this is, and John and I talk about this a lot, that at this stage of my career, at the stages of our careers, we actually know how things are supposed to work.
Yeah.
And we can talk through really complex scenarios very easily with the LLMs because of our experience. And I think that going forward, one of the most important skill sets that we will be trying to hire are people that have both experience, who are creative. You mentioned creativity, human
So
creativity, creativity and courage,
Yeah.
right?
Yeah.
And gone are the days where I have to just screen for the most technical person. Like, we need really technical people, but we also need people that know how to communicate and ask and prompt and move conversations forward. And I find I get the best results with my AI partners is when I'm treating them as an extension of human behavior.
Well, they are. You under the hood on how these LLMs and how the transformer technology works is basically you and your energy pokes into the void and a waveform comes back, but it's like an echo of you.
Yeah.
I was telling John before he came here, I can actually talk to agents of people and understand and hear how that person, like their mannerisms, I can tell that's your agent.
Yeah.
Because you've been talking to it. What's interesting, I think this is really, people are like, but like if the agents are going to take over work, absent the human, the agent reverts to the mean and does nothing. They don't just plan up goals.
No.
They require the human creativity to come in this energy, it's this weird waveform of I'm really thinking about this and it's really important and what if we did it this way, but I'm talking to the agent and then the agent talks back to me. The process that's happening is recursive learning that I'm doing.
That you're doing and the agent's doing.
Yeah, and that's why it's symbiotic.
And I feel like I've gotten better at my job as I've
100%.
adopted that practice.
Yeah.
It's fascinating to me.
It's very human what we do. I have to orate some of my half-cooked ideas to get them out. And sometimes I have a person to do that with, but sometimes it's the middle of the night and I just got to do it. I have this thing and I can come out with a transcription and bullet points of my midnight thought, and then we can synthesize it into some new piece of the network. But it's wild. We built the internet, we tokenized human intelligence, and now we created this thing where if you run enough current through it, you can talk to it and it gives you something back that feels smart.
Something meaningful.
Yeah, something meaningful.
And I love that. And so, like John, you at one click up in the organization, enabling this kind of work within the organization, it sounds like the OTS crew had the intrinsic motivation to go there, but speak broadly, like when when we first started introducing the idea that Cole's nuts about AI, how did the engineers react? Do they come at it with excitement? Is it trepidation? Because we got the results of our own internal survey, and I was fascinated by what we learned from what our staff told us. Are they afraid of losing their jobs? Like those are the kinds of questions I really expected to get.
So in an organization our size, I think the answer is all of the above.
Yeah.
You've got folks that are very excited and curious about it, still reluctant in some capacities, on up to folks that are just, feel, like it's a passing fad, and it won't stick around. What we've been trying to work through in our organizations is really kind of the practical applications and the utilization. I think we were a game changer when we went from chat agents to agentic and coding assistants. And so I think as we've demonstrated with cases like OTS, folks have that aha moment when they see how it can be applied. And I'm fascinated to watch the OTS team as an example. And there was one of the ways we've been able to be super successful. JJ's brilliant, of course, and very fascinated in the technology and has a great team. We're also a small team and pretty self-contained with regard to data sources and systems and things of that nature. And
Very
so
important.
we've been able to create that orchestration pretty quickly, where it's a little more challenging in some of the larger teams.
Right. You own all the data.
Yeah. So we have folks as fascinated in other areas that have maybe a few more hurdles to get to a point where we can orchestrate the same things. That said, I think as folks see those use cases, I think the light bulb goes off with how this can be an enabling technology to our workforce, to take away some of that mundane rote activity and add value to our folks to kind of unlock their full potential.
Yeah. And JJ said something that I really liked, that every business process has a goal, and you're hooking AI to that business practice. And I think once our teams start to context switch between AI can solve a configuration problem to AI can reconcile contracts, AI can write code, AI can validate, like all the things that all of our other teams do, I think some of them just need to see it.
Yeah.
They just need, like, the imagination needs to be perked.
You can apply it at so many different layers of a business structure. I mean, an executive, a CEO can go through and be like, I just want to look at my policy and my business units, and where's the friction? And let's smoke test friction on our policies. and that's just a policy evaluation. You can go through and be like, I want to look at like the invariance on this. Tell me my biases. What am I missing?
Wow.
And it'll just change the perspective. So you can apply this in so many different ways, which is, at the end of the day, we commoditized intelligence, and I want to think about things from 20 different angles. For the price of a token, that ends up getting very cost effective to look at. But I treat it with humility, because I also understand that because it is an echo chamber in some ways, I can go through and I can reinforce biases that I actually have, or I can create kind of a cacophonous rebounding of this is the way I think we should do it, and I'm losing perspective. There is an important part that humans are not, we're not trying to exclude them.
Right.
We're taking a human that I consider to be brilliant, and then they're connected agentically, and we're going to have a thoughtful conversation. But we can do something simple like, we misinform each other a lot,
Yeah.
not because it's intentional. Maybe I remembered something and we just want to fact check it. Well, there's a pocket fact checker here too, so we can make sure that we're talking about it. That's just so I can. If anybody needs use cases, I will talk forever about use
Well,
cases.
we're going to have you up in front of everybody talking about it, I can tell you that much, because once the imagination is unlocked, the solutions flow.
Yeah.
And I've seen it with very non-technical people already on campus, people doing some amazing things. I really need to ask you guys this, because I wasn't here during COVID, and I know we're switching gears here a little bit, but the network, it dawned on me when I was at Northeastern that the part of my organization that was the most invisible to campus suddenly became the campus. What did that look like for you guys when you recognized that, hey, the traffic is not the same, the direction is completely different, VPNs are a different beast now, everybody's video conferencing? What did that do to you guys in that, like, because remember, that was like a 5-day period where everybody on the planet went from, is this going to be a while, to we're shut down?
I mean,
talking about the WAN perspective?
Yeah, from the WAN perspective, you hit the nail on the head. Traffic changed directions in a way that we talked about. I'm predicting for a planned state. I have like a trajectory and a growth in a way that it enters the network. All of that changed because when everybody went home, they're now on their local internet connections, but they're still trying to get back to the university via VPN. So the VPNs aren't designed for everybody to be home streaming. So you end up having at the edge, there's a problem. We had like, campuses that were like, the VPN concentrators can't handle that. But the flow of traffic, most traffic is, from a WAN perspective, is asymmetric in that people download more than they upload.
Mm-hmm.
When you move out to another location at your house, you are uploading, and actually that's becoming my download. So you change the directionality, and all of my careful balancing goes out the window.
Yeah, because when I speed test at home, right, my download is through the roof. Upload is usually a third of that.
That's historically how it's designed, because if you think as a user on the internet, you're consuming, you're watching the stream, you're downloading the movie, you're watching the image. The upload is just to send a request for what you're downloading. So it changed the whole perspective. And then the other thing that was actually, we're still feeling some of the effects of it. COVID happened for the period that it did, and all of our metrics go to the floor. Now the question is, what happens when we come back?
Yeah, that was going to be my next question. What did you change for the better coming back?
Well, it was scary because we had to go in with all that change in traffic. We had to immediately near term try to solve problems that appeared that weren't there before, but that's the new network and we have to fix that. When people started coming back, we lost data and we said we were at this level. COVID happened, we've returned, and we're going to be fully back on campus. What level are we going to come back at? And is the traffic going to be different? Could I draw that linear projection? No, it was different. So we basically lost our map of where we were headed. So we just planned for it to be higher. And then put a little bit more in, and now we're tuning after the fact. But big things like we had this year for the agentic flows and stuff, nobody was actually planning. That's a 0 to 1 change. The traffic
Right.
patterns are different with agents everywhere. This is an R1 university. We are a place that gets spidered for data
Yep.
from all of these agents trying to find stuff.
Yep.
So we are a source now.
So it is changing. So let's just sort of leave it with this. If there was one thing that you guys would want our one listener out there to know about the work that we do for the university, what are those thoughts?
That's a good question.
You know, I think I would want them to know we have, you know, you mentioned in the initial comments that this is an area that folks don't normally think about
Yeah.
when they think about IT. It's kind of bedrock capability, but the thought, dedication, perseverance, intelligence of the folks that support them at this level may not be seen directly day in and day out, but what I hope they take away from this is a view into a world where folks are working diligently
Yeah.
to support everything that goes on at this institution behind the scenes, maybe not always you know, in the forefront, but working very diligently to make sure that everything else that's built on top of it works.
I love that, and I couldn't agree more. I mean, this whole knowledge factory that we operate here is driven largely by the movement of ones and zeros, and I can't thank you guys enough for not only what you do for UT Austin, but obviously what you do for the state of Texas, and really education. And we're blessed to be in a mission-driven culture here where we think about our students and our faculty and the discovery of knowledge. So I appreciate you both coming today and spending some time, opening my eyes to some things, teaching me some stuff. I loved it. So thank you both very much. So thanks so much to everybody out there for tuning in to another ET Talk. JJ and John, thank you both so much. And we'll see you at the next one. Welcome.
Thank you.
Thanks, Cole.
Yeah, thank you.